Have you ever wondered why humans have been able to venture into the vastness of space, yet exploring the ocean's mysterious depths remains such a daunting challenge? It's a thought that has fascinated scientists, explorers, and dreamers for centuries. Despite the undeniable allure of both frontiers, there is a stark contrast in how we approach these two vast, unexplored territories. Space exploration seems to come with fewer hurdles, while the ocean remains one of the most difficult environments for us to conquer. In this article, we will dive deep into the science behind why this is the case, and how this contrast helps us understand not only the challenges of exploration but also the tragic implosion of the Titan submersible. This comparison is not just about distance, technology, or resources, it's about pressure. While space offers a relatively pressure-free environment, in the vacuum of space, the ocean presents one of the most extreme forces on Earth, the crushing pressure of water that increases dramatically the deeper you go. The challenges posed by these two environments reveal why space exploration has advanced more rapidly than ocean exploration, and how pressure plays a crucial role in these journeys. The pressure dilemma: space versus ocean. When we embark on a space mission, we leave behind the Earth's atmospheric pressure. As our spacecraft ascends, the pressure around us rapidly decreases. This reduction in atmospheric pressure allows spacecraft to move through the vacuum of space with relative ease. The lack of air resistance makes space travel possible, and once in orbit, astronauts can float freely in the microgravity environment, experiencing weightlessness and defying the gravitational pull that binds us to Earth's surface. Space, therefore, is a vast, largely empty environment where the primary challenge is escaping Earth's gravity and the potential hazards posed by radiation and space debris. Once past the Earth's atmosphere, the environment is much less taxing physically, and much of the focus shifts to navigation, equipment reliability, and the ability to sustain human life in space. The ocean, however, is an entirely different story. As we descend into the ocean's depths, the pressure surrounding us increases dramatically with every meter we go deeper. The deeper we go, the greater the force exerted by the water. Unlike space, the ocean's depths are full of obstacles: darkness, cold temperatures, crushing pressures, and the risk of equipment failure. At the greatest depths of the ocean, such as the Mariana Trench, the pressure can exceed 1,000 times that of sea level. The immense force of this pressure is capable of crushing submarines and deforming even the toughest of underwater vehicles. For every 10 meters you descend, the pressure increases by 1 atmosphere, an unrelenting force that makes deep-sea exploration a huge challenge. A shrinking cup at 3,200 meters. To illustrate just how extreme the pressure of the deep ocean can be, let's consider a small cup. When this cup is at sea level, it is the standard size we are all familiar with. However, if we were to take this same cup down to 3,200 meters below the ocean's surface, the pressure would cause the cup to shrink significantly. This is not an exaggeration. The weight of the water pressing down on the cup at that depth is so immense that the cup's structure cannot withstand it. Imagine yourself as a diver, descending to those depths. You would be feeling the force of this pressure on your body. It's enough to crush the human body and any non-pressurized object, no matter how strong it may seem at the surface. What exactly is pressure? To understand why the ocean exerts such a force on us, it's essential to first grasp the concept of pressure. In physics, pressure is defined as the force exerted on a specific area. Simply put, is the effect of force spread over an area. For example, if you press on an object with a large surface, the pressure is less than if you press on it with a small, sharp object. Think about how much easier it is to cut through a fruit with a sharp knife. This is because the knife's blade is thin and focused, concentrating the force on a small area, making it much easier to pierce. In the case of fluids like water, pressure increases as you go deeper. This is because the weight of the water above you adds to the pressure you experience. The deeper you go, the more water there is above you, meaning the pressure continues to increase. The formula for this is P equals H rho G. P equals H rho G. P equals H rho G, where P is the pressure, H is the depth, rho is the density of the fluid, in this case, water, and G is the acceleration due to gravity, approximately 9.81 meters/s squared on Earth. This formula shows that the pressure you experience increases with depth. For example, at 10 times the depth, the pressure would be 10 times greater. This explains why deep-sea divers experience such intense pressure as they go deeper. Interestingly, air is also a fluid, so this same principle applies to the atmosphere. At sea level, the weight of the air molecules above us creates atmospheric pressure. As we ascend, such as in an airplane or mountain climbing, there are fewer air molecules above us, so the pressure decreases. When we reach space, where there are virtually no air molecules to exert pressure, the pressure approaches zero. This demonstrates why space, with its near absence of pressure, presents fewer physical challenges compared to the overwhelming pressure of the deep ocean. Air pressure versus water pressure, a clear contrast. To give you a clearer understanding of this comparison, let's look at how pressure differs between air and water. While the air pressure at sea level is 1 atmosphere, the pressure we experience from the weight of the air above us, it takes a relatively small amount of water to exert the same pressure. Just 10 meters of water depth produces the same pressure as air at sea level. Since water is far denser than air, the force exerted by water increases much more rapidly as you descend. Now, imagine the height of Earth's atmosphere, which stretches about 120 kilometers above us. Compare that to the ocean. Its maximum depth, the Mariana Trench, plunges down just 36,000 feet, around 11 kilometers. So, in terms of depth, we can go much further into space than we can into the ocean, thanks to the drastically different ways pressure behaves in these environments. Space versus ocean, a stunning comparison. Let's put this into a more tangible perspective. The deepest part of the ocean, the Mariana Trench, reaches a depth of about 36,000 feet. On the other hand, the International Space Station orbits Earth at an altitude of 250 miles, or about 1,320,000 feet. When we compare these two distances, it becomes clear, we've managed to send humans and machines far into space, much further than we've been able to go beneath the ocean's surface. The reason for this is simple: the ocean's extreme pressure makes it far more difficult and dangerous to explore than the relatively pressure-free environment of space. Exploring the ocean, progress despite the immense challenges, we have still made impressive progress in exploring the ocean's depths. Advances in technology have allowed us to send specialized robots and submersibles to the most extreme ocean environments. For example, in 2012, filmmaker James Cameron made history by descending to the bottom of the Mariana Trench in a submersible, becoming the first person to do so solo. He completed the journey 33 times, demonstrating the incredible human ingenuity required to navigate the deep ocean. However, even with all these technological advancements, deep-sea exploration is still a highly dangerous and expensive endeavor. The complexities of building equipment capable of withstanding the ocean's immense pressure, combined with the need for specialized training, resources, and support, make ocean exploration a far more costly and perilous endeavor than space exploration. The imbalance, why space exploration gets more attention. Another reason space exploration has advanced further than ocean exploration is the greater governmental support for space initiatives. Space exploration has long been driven by national pride, technological race, and military competition. The space race between the United States and the Soviet Union fueled a massive influx of funding, resulting in rapid advancements in technology and exploration. Space, with its vast potential for discovery, economic development, and even the possibility of colonization, continues to captivate global interest. In contrast, ocean exploration has not seen the same level of investment or political support. Governments have been less inclined to focus resources on exploring the deep sea, despite its immense importance to life on Earth. The lack of a competitive race for ocean exploration has made it a less glamorous and less prioritized field. Conclusion: why space exploration is easier than ocean exploration. In conclusion, while both space and the ocean present immense challenges to exploration, space is arguably the easier frontier. The lack of pressure in space, combined with technological advancements that allow us to navigate the vacuum of space, make it more accessible than the crushing pressure of the deep sea. The challenges posed by the ocean's depths, along with the density and force of water, create an environment that is much more difficult to overcome. While we've made significant strides in both fields, space exploration remains the more advanced and accessible of the two. As technology continues to evolve, it's possible that we will begin to unlock more of the ocean's mysteries. But for now, space continues to captivate our imaginations and drive the next generation of exploration. So, the next time you look up at the stars or think about the uncharted depths of the ocean, remember, while both are vast and mysterious, space holds a distinct advantage in terms of accessibility and exploration.